Alrighty, let's start this new lesson now. And this lesson is all about solving problems using the log laws that we did before. So I'm just going to put this, let me just write this out, type this out. So we're going to put this here, we're going to put maybe blue, and we're going to say log problems. Or maybe I could say logarithm problems. Alright, and the objective for this lesson, objective is simply to solve logarithmic equations, right? And we're going to use a lot of what we learned previously, right? We're going to take our algebra, we're going to take our log laws, and we're going to take our quadratics knowledge, and we're going to use that now. And what I want you to remember is one thing, and I'm just going to state this log property here that you're going to remember it. Log property, right? You must remember this, that what logs do is that they reverse the index operation, right? We're reversing the index operation. So that means if you have the log to the base of something, of a number or some expression, it's going to be and it's equal to log to the same base of another expression, then x is going to be equal to b. And this is something that you learn in algebra, and this is something that you dealt with when we deal with exponents, right? When we say something like 3 to the x is equal to 3 to the 2x plus 1, right? Sorry, no, 3 to the x something something something, and we can be able to figure out, well, 3, and we're able to figure out that x is equal to 3. It's the same kind of thing here, right? Just because we did it with indices, we're going to be able to do it as well with logarithms as well, right? But there's a few conditions that you need to remember. Because we're reversing indices, you have to remember that where x must always be greater than 0, right? The answer is always greater than 0. Why? Because remember, if it is that we have log to the base a of b equals c, then c to the power, sorry, a to the power of c is going to be equal to b, right? In this here, notice that the base, which is here, is going to be a, and this up here, which is the b, is going to be a result, right? It needs to be greater than 0 because you cannot have it that x is going to be anything other than, sorry, less than 1, right? Most of the time, a to the power of 0 is also equal to something, so you can't have it going the other way. Another thing that you're going to have to pay attention to is because of the same exact thing, b is going to be greater than 0 as well, right? So x and b, which is the expression inside of the logs here, going to have to be greater than 0. A is also going to have to be greater than 0, and a is also going to have to be not equal to 1. Now you might start to think to yourself, right? You might start to think to yourself, well, okay, if it's greater than 0, it's not equal to 1, why not just say, greater than 1, right? So why not a greater than 1? Well, that's because everything between 0 and 1 is basically a fraction. And those fractions are used, your fractional bases. Fractional bases. Fractional bases exist, right, between 1 and 0, or 0 and 1, however you choose to say it. Example, if we have something like a half, right? A half exists in between there. So we can't get rid of the fractions just yet. So that's why we have this condition where a has to be greater than 0, but a can't be equal to 1, right? So it's greater than 0, but it cannot be equal to 1. There is existing fractional bases in between there. And why is that we can say that? Well, okay, if I have something like, you know what, let me just write this example differently. If I have example of a half to the power of a square equal to a quarter, then we can say log to the base of a half raised of a quarter is going to be equal to 2. So you notice here that the base, which is a half, there is a possibility of a fractional base. We can raise fractions to a power, right? We can raise fractions to a power. We will get another fraction, yes. So therefore that means we can find the log to the base of that fraction of a number and be able to still get that 2 out on the end here, all right? All right, so now that we have all of this explanation, let's start on a new page and we're going to look at some examples, right? We're going to look at some examples, and this here is example number 1, and we're required to solve, what are we going to solve? We're going to solve that the log to the base of 5 of 2x plus 5, close bracket, minus log to the base of 5 of x minus 1 is equal to 1, right? Equal to 1. Okay, so let's go about solving that. And we can say, given that log to the base of 5 of 2x plus 5 minus log to the base of 5 of x minus 1 is equal to 1. I'll just call this equation 1 in case I need to refer to it later. I can then say that I need to figure out some valid solutions. Remember, we said already that the expressions that we find in the log of need to be greater than 0 in both of the instances. So that means I need to find valid solutions for this and valid solutions for this condition here, right? So the valid solution is found where 2x plus 5 must be greater than 0. And x minus 1 must also be greater than 0. Okay? The expression must be greater than 0. So that is that x must be greater than negative 5 on 2. And x must be greater than 1. Okay, well, let's draw a number line and see how this stacks up. So let's draw the number line right here. And we're going to have this here. Minus 5 over 2 is going to go over here. 1 is going to go over here. And let's draw some arrow directions. Now, this is just an open circle, right? This is just open circle. So let's go on and draw the directions here. Greater than 5, negative 5 on 2 goes in this direction. Greater than x, x greater than 1, that's in that direction. So therefore, that means that I have this region here, right? So the valid solution region is when x is greater than 1. So in the situation where x is greater than 1, this here will be positive and this here will be positive. So therefore, we need this answer, any answer that's greater than 1 for the valid solution. Now, let's solve the problem now. So we have this now, this here, and what we're going to do is we're going to be using it's negative, so we're using the quotient law. So we're going to say using the quotient law of logs, 1 becomes, it's going to be log to the base of 5 of 2x plus 5 all over x minus 1. And then that's equal to 1. Now, remember, we have a law that says log to the base of a is equal to 1. So that means 1 can also be written as, since I have log to the base 5 here, I'm going to say log to the base, let me write that differently, but log to the base of 5 is going to be equal to 1. So I can replace this here, right? I can replace this here. I can put 2 into equation number 1. So I can say substitute 2, and this here is still going to be labeled as equation 1 actually, right here. So substitute 2 into 1. You know what? Maybe I should call it like 2, and then I call this 3, so that when I make the reference, I'll say 3 into 2, and that makes sense because it don't confuse you anyway. Right, so this is equation 3. I'm going to put equation 3 into equation 1. I'm going to end up with something that looks like log to the base of 5 of 2x plus 5 all over x minus 1, close the bracket, is going to be equal to log to the base of 5 of 5. And now I have log to the base of 5 on both sides, and according to the principles that we did before, that means that, 2x plus 5 over x minus 1 is going to be equal to log, well, it's going to be equal to 5. All right. And from there, then that means that I'm going to have therefore that I'm going to multiply both sides by x minus 1. I'm going to have 2x plus 5 on this side. And on the next side, I'm going to have 5 into x minus 1. I'm going to expand. So expanding. Oopsie. Right? That's because I didn't scroll long enough. Expanding here, and we're going to have here that 2x plus 5 is equal to 5x minus 5. What am I going to do? I'm going to put all the x's on one side and all the numbers on the other side, and to do that, I'm going to minus 2x from both sides, and if I'm minusing 2x from that side, I am going to add 5x on that side so I can get rid of that. So I'm going to do this. To both sides, I'm going to minus 2x and I'm going to plus 5, and that is going to leave me with 10 on this side when I'm just going to switch sides of it. So I'm going to say 5x here. No, wait, the minus, so that's 3x, right? So 3x on that side, and then I am going to add on that side, so this is going to be 10, and therefore I'm going to divide here both sides by 3. So I'm going to get here x, and then I'm going to get here 10 over 3. All right, now, since 10 over 3 is greater than 1, then x equal to 10 on 3 is a valid solution, right? So this is a valid solution for this here, right? And then, well, I think we can go on to the next number here. Remember, this is the condition that we had. Whatever value we have to get, it has to be greater than 1. This here is definitely greater than 1, so that's why it's a valid solution. And let's do another one. Eventually, you will see why this is important later on, right? It's not going to always be the case that you're going to have everything is a valid solution when you solve it. So let's continue solving and we'll eventually come across one. So solve log to the base of 3 of x plus 4 and then plus log to the base of 3 of x minus 2 is going to be equal to 2. And then we're going to say given log to the base of 3 of x plus 4 plus log to the base of 3 to the base of 3 of x minus 2 is going to be equal to 2, and this here is going to be 1, and the valid solution exists where x plus 4 is greater than 0 and x minus 2 is greater than 0. Okay, so that is x greater than negative 4 and x greater than 2. Right, so let's draw a number line and see exactly what is the overlapping region so that we can figure out where the valid solution needs to exist. All right, so the valid solution would exist where, well, this is negative 4 here. This is 2 here. These are both open circles. And we're looking at the direction of, well, greater than negative 4 is this direction. Greater than 2 is this direction. So that means that we're going all the way over here. All right, so the valid solution, so the valid solution region is x greater than 2, right? So once x is greater than 2, it's the valid solution region, and we can say using the product law of logs, 1 becomes, what does 1 become? Well, product law here, that means that this multiplied by this. So we're going to have here log to the base 3 of x plus 4 and x minus 2 close bracket is going to be equal to 2, right? And we're going to use the index relationship again, but 2 log to the base of 3 is equal to 2, right? Why am I saying it like that? Well, log to the base 3 of 3 is going to be equal to 1. Log to the base 3 of 3 is going to be equal to 1. Then 2 by 1 is just going to give me 2. And another way I can write this is log to the base 3 of 3 to the second power, right? This way I can just simply compare the logs and I can get this something looking like this. Let me just say this here is equation number 2. And let's say that this is equation number 3, and I can say substitute 3 into 2. All right, I can substitute equation 3 into equation number 2, and I will get something looking like this: log to the base 3 of x plus 4 x2 and equal to log to the base 3 of 3 squared, and just put that in brackets. So now the brackets are equal to each other. So that means that x plus 4 x minus 2 is going to be equal to 3 to the second power, right? And 3 to the second power is 9, so we're going to just expand. So expanding, and we will have, well, I'm going to use x by minus 2. So x squared minus 2x, and then 4x, and then 4 by minus 2. So that's positive 4x minus 8 equal to 9. And I'm going to minus 9 from both sides, and I'm simplifying as I go along. So I'm going to get x squared plus 2x. I'm going to minus 9 from both sides, minus 17 equal to 0. Okay, so we end up with something that is quadratic, and we already know how to solve quadratics. But I am looking at it and I'm not seeing easy factorization. And I don't like completing the squares so much, so I'm going to using the quadratic formula. Maybe I should put this as capital Q. Quadratic formula when a is equal to 1, b is equal to 2, c is equal to minus 17, right? Then, I could write then on this sentence here. Then we can say that x would be equal to minus of b, which is 2, plus or minus the square root of b squared, which is 2 squared, minus 4 into a, which is 1, into c, which is negative 17. Close the bracket. Divide all of that by 2 into a, which is 1. All right, let's simplify a little bit. So x here would be minus 2 plus or minus. And let's see, that's 2 squared was going to give me, I'm going to write it in yellow. 2 squared is going to give me 4 here. And then I have 17 by 4, which is 40, 28, 68. So plus 68. And then I'm going to add these two together. That's going to be, sorry, there's 68. And then add 4. So that is 12. And that means I'm going to get 60 plus 12, which is 72. I know that was easy, but I just fumble. Let's see. So the square root of 72 divided by 2. Well, I'm seeing a factor of 2 all over the place, right? I'm seeing a factor of 2 all over the place. So what I can do is, I can say 36 by 2, and I get that, and I get 4 by 9. Okay, let's see if I can do this. I can say x is equal to minus 2 plus or minus. Let's say root of, let me just write it out. Let's see, this is going to be 4, 9. Yeah, let's see. So we're going to have 2 times 4 times 9, right? All over 2. Okay, I'm going to add an next page. And let's say x is going to be equal to minus 2, open bracket, 1 plus or minus. The square root of 4 is just going to be 2, and that can factor out on the front, right? So this here gets factored out to the front. And then square root of 9 is going to be 3, so that it becomes out in the front as well. The only thing that can't square root inside is the 2, so I can just put it back here like that. Right? Surds will help you understand that. Divide here by 2, and then cancel this off here. So I'm going to get here that x is going to be minus 1 plus or minus, you know what, let me write this out like this, minus 1 plus or minus 3 root of 2. Okay? So I'm going to get my two answers right there. So now, either the answer is x equal to minus 1 plus 3 root of 2, or the answer is x equal to minus 1 minus 3 root of 2, right? So it's either one or the other or both. And let's do a calculator to try and figure out which one is which. So let's see this one. So this one here is minus 1 plus 3 root of 2, right? This is well, that's the simplest form, and this here is 3.2. Okay, so this here x is approximately equal to 3.2 dot dot dot, expressing that it have a whole lot of things after that. And let's check this one. X is going to be I'm just going to change that negative sign, that positive sign there to a negative. See, backspace that negative, and we get that. We're going to change the answer, negative 5.24. Right, so negative 5, and let me just put that approximation symbol, approximately negative 5.24 dot 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 some other things. And we need to we have a valid solution region already that we checked. The valid solution region that we have is greater than 2. So let's see which answer is greater than 2. So this one is less than 2. This one is greater than 2. So this one is a valid solution, valid, and this is an invalid solution. Okay, so since minus 1 plus 3 root of 2 is greater than 2, then x is equal to minus 1 plus 3 root of 2. Okay, is a valid solution. Right? So this is the purpose of having a valid solution region, so that anytime you get your answers at the end, you can check it against your valid solution region and ensure that you have a valid answer. If you don't have a valid answer for any of them, then you have no solution overall. But usually, most of the time, one of them is supposed to work out. All right. Let's go on to the next example. We waste like half a page. I'll just put the next example right here. Example number 3. And we're to solve 2 log to the base 2 of x minus 3, close bracket, minus log to the base 2 of x equal to 1. And that would mean that, well, let me just work this a little bit. So given 2 log to the base 2 of x minus 3, close bracket, minus log to the base 2 of x equal 1. We'll call this equation number 1, and then we'll say the valid solution exists where we need x minus 3 to be greater than 0, and we need x to be greater than 0. Well, that means that x here is going to be greater than 3. Right? So let's look at our valid solution region. So we have our number line here, we have a 0 here, we have a 3 here, open circle, and for these, we know that we want greater than, so greater than this way, greater than this way. Now, I don't think I have it here, but if it is that ever the sign of x causes this arrow to change in direction, don't forget to do this. It will help you find your region easier. So let's see. Right? Dot, 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 dot. Right. So the valid solution region is x greater than 3. Right? So the valid solution region is x greater than 3. And let's see. Using what we're going to use here, using quotient. Right? So using the quotient law of logs, 1 becomes log of log base 2. Well, actually, this is going to reach the second power. So this here, this log base 2, x minus 3 raised to the second power, and then divided by x. So that, right? So we're going to get here log to the base 2 of x minus 3, close bracket around it, square it, and put the x here. And then this here is equal to 1, right? And we're going to change this 1 into a log base 2 form. So we're going to say, but log to the base 2 of 2 is equal to 1. So we can simply take this and rewrite it to look like this: log, oopsie, log to the base 2 of x minus 3 close bracket around it squared over x close bracket is equal to log to the base 2 of 2. And we're going to get here, therefore, that x minus 3, and we're going to square that over x, is going to be equal to 2. All right. And then all we're going to do from there, I'm going to add new page now. All we're going to do from there is going to multiply by x throughout. So we're going to get here x minus 3 squared is equal to 2x. And then after that, we're going to expand. So we're going to say expanding, and we're going to get x squared minus 6x plus 9. Right? And that's equal to 2x. And I'm going to minus 2x from both sides. I'm going to get x squared minus 8x plus 9 equal to 0. Right? Again, we get a quadratic. Do I have to use quadratic formula on this one? Let's see. 9 is the one here, and it's 1 by 9 and 3 by 3. So to get that as negative 8, I'm going to need a negative 9 and a positive 1, which is not going to work out to a positive 9. So therefore, I'm going to have to use quadratic equation. So using the quadratic formula, and erase all of this, when a is equal to 1, b is equal to minus 8, and c is equal to 9, we can get a solution for each one of these. We get that x is going to be equal to minus b, which is minus 8, plus or minus the square root of b squared, so minus 8 squared, minus 4 into a, which is 1, into c, which is 9, close bracket, square root that. After done, divide all of that by 2 into a, which is 1. And then we're going to simplify each of this. So minus minus 8 is just going to simply be 8 plus or minus. 8 by 8 is 64. And then this here, 4 by 1, that's minus 36. And 64 minus 36. And that is just going to be 6 minus that is 30. 30 minus 2, which is 28. Okay, so this here is root of 28. Root of 28 all over 2. And I think I can factor out a 2 somewhere inside of there. Let's see if we can factor out a 2 somewhere inside of there. So x is equal to, let's say 8 plus or minus the root of 7 times 4. There's my 2 right there. All over 2. So this means that x is equal to 2 into 4 plus or minus 2. So that's root of 7. And then divide by 2, so this cancels. Okay, so x is going to be equal to 4 plus or minus the root of 7. Now I just have to simply take one of my answers and find out which one belongs to my valid region. So either x is equal to 4 plus root of 7, or x is going to be equal to 4 minus the root of 7. X is going to be approximately equal to, you know what, let me just do the calculator again. So calculator, and we have 4 plus root of 7. This answer is 6.645. Approximately 6.64 ... And the other one is going to be minus in root of 7. I can have both regions valid. I can have both answers valid. Let's see what we get here. This here is correct, and then it's 1.35. So this here is 1.35 something something something. Right? Now, let's go back up and see what our valid region is. Our valid region is x greater than 3. Okay, so our valid region x greater than 3, that means this one here is the valid region. So since 4 plus root of 7 is greater than the valid region of 3, then x equal to 4 plus root of 7 is a valid solution. Right? So that is the valid solution for this equation here, to solve this equation here. Right? Let's go on to another one. So this is going to be example number 4. Example 4. And this one here, we're going to say something like solve log to the base of 4 of 3x plus 1, close bracket, equal to log to the base of 4 of x plus 7, close bracket, minus log to the base of 4 of 2. Ooh, that's a lot. Okay, so given that log to the base of 4 is 3x plus 1 equal to log to the base of 4 of x plus 7 minus log to the base of 4 of 2. We'll call this equation number 1. And we want to find out valid solution region. So we have 1, 2, 3. And well, the last one is not an expression, so that's valid already. So let's see. We have here that the valid solution exists where 3x plus 1 is greater than 0 and x plus 7 is greater than 0. Ugh, that don't look right. Greater than 0. Alright, so that means that x is going to be greater than negative 1/3 and x is going to be greater than negative 7. So with my valid solution region here, I can see that I have negative 1/3 plus negative, oopsie, no, negative 7. Negative 7, and then here's negative 1/3. And then here we're going to say greater than this, greater than this. So that means that our region needs to work right in there. Okay? All right, so we have our region, and let me just state that region. So the valid solution region is x greater than negative 1/3 using quotient law of logs. 1 becomes what? Quotient law, this one here, this x plus 7/2. Okay, so that's log base 4 3x plus 1 log base 4 3x plus 1, and then this one here on the other side is log base 4 x plus 7/2. So log base 4 x plus 7/2. All right, so that is that. Therefore, that means 3x plus 1 is going to be equal to x plus 7/2. I'm going to multiply by 2 on both sides, so I'm going to get here that 6x plus 2 is going to be equal to x minus 7. I'm going to minus x from both sides, and I'm going to minus 2 from both sides. So I'm going to get here 5x, and this here is going to be minus 9, and then x is going to be minus 9/5. Right? So now I can see where this can go. Let's see. This is 7. Did I write this down correctly? Just want to make sure. Felt like I rushed it. 2, 2, right? This. Oh, you see? I went from a positive to a negative. So this here is supposed to be a positive. Right? So that's supposed to be a positive. So I'm minus 2 from both sides. And yeah, so this here is no longer that. This here is 5. Right? That there is 5. So that means x is equal, when I divide both sides by 5, that means x is equal to 1. Alright? And since 1 is greater than negative 1/3, then x equal to 1 is a valid solution. Alright? And let's go on to the last one that I have to do now. And this here, example number 5. We're going to solve log to the base 3 of 2x plus 5, close bracket, minus log to the base 3 of x minus 1, oopsie, x minus 1, close bracket, equal log to the base 3 of x plus 2, close bracket, and we're going to start writing that. So given log to the base 3 of 2x plus 5, close bracket, minus log to the base 3 of x minus 1 is equal to log to the base 3 of x plus 2 here, we're going to look for the valid solution region. Wow, we have three situations here now. So given that, we're going to say that the valid, you know what, that's choking up a little bit too much. Let's say the valid solution exists where, let's see, we have three situations here. So we have 2x plus 5 must be greater than 0. And we have x minus 1 must be greater than 0. Must be greater than 0. And we have x plus 2 must be greater than 0. So we have three regions here. And that means that x would need to be greater than negative 5 on 2. And x would need to be greater than 1. And x would need to be greater than negative 2. Right? So let's write that number line down. So number line goes right there. And we're going to have three values. Let's arrange them in order. So this here is about, this one here is 2.5, this one here is 2, and this is 1. So okay, that means that we're going to have here negative 5 on 2, then we're going to have here negative 2, and then we're going to have here, which is 1. And that's how they will line up on the number line in relation to each other. Right, so I have here 0, open circle, open circle, open circle, everything still remain the same, nothing shifts sides. And I'm going to say greater than this, greater than this, greater than this. So therefore that means we're looking at the region that is greater than 1. Okay, so let's look at that here now. So we can say here, so the valid solution region is x greater than 1. Right, so that is x greater than 1. And we have here a quotient, so let's use a quotient. So using the quotient law of logs, 1 becomes log to the base 3 of log to the base 3 of what, right? 2x plus 5, x minus 1. 2x plus 5, x minus 1, close bracket, equal to log to the base 3 of x plus 2. Right? So then that means that this is equal to that. So we can say so 2x plus 5 over x minus 1 is equal to x plus 2. All right. I'm going to put a new page, and then what we're going to do here, boy, we're going to multiply everything by x minus 1, not 2, 1. All right, x minus 1, minus 1. All right, so we're going to multiply everything by that. That means we're going to end up with 2x plus 5 is equal to x plus 2 into x minus 1. So then we're going to expand that. So we're going to say expanding, we're going to get 2x plus 5 is going to be equal to x squared minus x plus 2x minus 2. Right, so that's this by this, this by this, this by this, and this by this. Okay, so from there we're going to simplify, and we're going to get that 2x plus 5 is going to be equal to x squared plus x minus 2. And then what we're going to do, we're going to get rid of everything on this side. So I'm going to say we're going to minus 2x minus 5 from both sides. And then I'm going to switch this over. So I'm going to minus everything on this side. I'm going to switch this over to that side. And that is going to be equal to x squared minus 2x minus that. So it's minus x. And then negative 2, negative 5 is going to be negative 7, and it's going to be equal to 0. Can it factorize 1 by 7? No. 1 by 7 cannot sum to give me a 1, so it cannot factorize easily. So that means using the quadratic formula, when a equal to 1, b equal to negative 1, c equal to negative 7, we get that x is going to be equal to minus open bracket b, which is minus 1, plus or minus b squared, which is minus 1 squared, minus 4 into a into c, which is negative 7, close the bracket, square root this, all over 2 over a, which is 1 in this case. Right, let's go about simplifying that. So simplifying that, we're going to get that x is equal minus minus is going to make that just a 1 plus or minus. Let me just write this on the top here. So 1 squared is 1, and then 4, it's 28. So we're going to get 29. So plus that, 29. Yes, so we have the square root of 29 divided by 2. I don't think I can make anything out of that. I think 29 is a prime number. Yeah, it is. So not supposed to be able to break that down any further. Okay, so either x is equal to 1 plus the root of 29. Let me write that better. Root of 29 over 2, or we can say that x is equal to 1 minus the root of 29 over 2. All right. In this case, x would be approximately equal to, let me get my calculator here for this one. 1 plus root 29, oopsie, we just do it as a fraction. 1 plus root 29 all over 2, and that answer is in its lowest form, and we get approximately 3.192, so on and so on and so on. So 3.192, so on, so on, so on, so on. Let's do the same thing again for the other one, and this means that I'm just going to have to change that positive sign into a negative sign. Minus, equal, it's a lowest rational form right now, and this here is negative 2.192, and so on and so on and so on. So x is approximately 2.192, and so on and so on and so on. Right? Let me just make sure. Yeah, 2.192. Okay, so we have both of them. And what's the region we need? The region we need is any region that is greater than 1. Oh, well, if that is the case, we have a region here that's greater than 1. I don't think this is correct, now that I'm looking at it. 1 minus the root of 29. Root of 29 is either between 5 and 6. So it's 5 point something. I know that for solve. So 1 minus 5 point something is not supposed to be a positive answer. Something is wrong with my calculator. Let me just check that calculator value over. 1 minus the root of 29. See, negative 2. Negative. Right? So we only have one valid solution. All right. So that means so since since 1 plus the root of 29 over 2 is greater than the solution region that we have is what again, boy? Region is 1. So it's greater than 1. Then x equal to 1 plus root of 29 over 2 is a valid solution. Right? And right? And that's it. Now you know how to use the laws of logs to simplify expressions to work on problems like this where you need to find x. And we notice that we bring in some of the inequalities that we know. Notice that we bring in some of the quadratic formula, the methods for solving quadratics that we know, right? It's not usually going to be this difficult. This is about as difficult as it's probably going to get when you're doing a solution. Whew, this is a long solution, boy. 1 page of a solution. That's fine. Anyway, so this is about as long as it's going to get for a solution. You're not going to get anything more challenging than these. And most of the time I give you problems, it's going to be more challenging than what you're going to find on the exam, but it's easy for you to understand. It's not that much of a higher level. All right? Okay, so that's the end of the lesson. If you have any questions, comments, issues, please let me know. And I will see you in the next lesson that we do. Bye. Enjoy the rest of your day.